Okay, so I'll just start. So last time Christian and Gonzalez were here, and so last time we kind of did me using my iPhone. It's kind of, I don't know. I don't really like it. We're gonna try something different this time, and at the end you can tell me if it's worse or better or whatever makes you happy. So I'm gonna scroll through the key on my computer and I'm gonna screen share it with you. And then I have little time stops that I'm gonna stop and show you some videos, at least for like visuals. So this is session 11. We're gonna start with session 11 material and we're just gonna go for the hour. If we don't get through all of session 11, that's okay. Last time it took us like an hour and a half to get through like, you know what I'm saying? We're not doing that. It's okay. We're just gonna go at our own pace. I did talk to Scoggins today, and because your exams are gonna be online, you're gonna have a minute per question, and I don't think you're gonna be able to go back. So the deal with that is kind of need to know your information, because you don't really have time to Google anything or use your notes, right? On some of them, yes, and some of them, no. Depends on how fast of a test taker you are. If you do need testing accommodations and you have paperwork for that, I'm sure that this is a good time to submit that. Reach out to Scoggins. I'm sure he'd be really helpful and understanding. So I have a whiteboard and I have a bunch of things. So I'm going to try this. At any moment, if it feels like this is not working, please tell me because, you know, I'm trying to work on it. Does anyone have any questions or concerns or anything they want to talk about before we start?
Honestly, I have no idea what's going on with that class right now. I'm gonna just be honest.
Well, he hasn't uploaded any videos since that joint video.
Yeah.
And actually, your lectures have been shorter because it's been like 45 minutes total because the fractures video is like 15 minutes and then the joints video is like 30 minutes. So your class time's cut down, which is nice, but then we have a bunch of other things to do.
Did he post like the notes that we would have taken in class?
Like do you mean like the paper, like the copy, like the blanks?
Like ones that are already like filled in, like the PowerPoint or something.
He posted that video, so he posted 2 videos, and in the videos he's just going through the written PowerPoint. So that's where you would get all your answers for the notes. So you have to watch the video to do it all. No way. Is this Eric for reals? Hold on. Eric. Oh my gosh. Can you hear me? Okay, Eric. Oh my gosh. I can't believe it.
I'm gonna go grab
it. What did he say? A snack? Okay, we can start going. I don't know, man. Does anyone else have anything they want to talk about or concerns or whatever? No, we're good. Feel free to stop me. I'm going to share my screen with you. So we're starting at session 10 that's on the website, and I'm just going to kind of go through the key with you. If you were here on Tuesday, we are going to go over the material that we went over that was extra again, because we're just going to do it fresh because I know y'all were tired and I was tired, and I'm thoroughly believe that you don't remember what we talked about. Neither do I. It's fine.
I had to take a nap
after. Say that again?
I had to take a nap right after.
Oh yeah, no, I was like, people were trying to talk to me. I was like, get away from me. I need time to myself, please. Okay, look at this. We have 8 Oh, that is such, Natalie, you're so smart. Okay, so at the bottom, I know a lot of you know this. If you don't, if you'll just chat me, you can select to chat me. If you'll just send me your UIN so that I can write it down on this silly sign-in sheets, I would appreciate it. And I'm going to write those down really quick.
Wait, what do you want us to do?
Will you send me your UIN via the chat? Just send it to me though. Just because then no one else has to see your stuff. Okay, cool. All right, let me write these down really quick and then we can go.
Is the attendance just something for you, like for you to keep, or is it, do we
I
get any?
submit it online. So I think it's so that the hey Eric, will you send me your UIN privately to me in the chat? You know, yeah, your 000 number. So I submit the attendance online and I have to submit it for like
Oh,
my payroll or whatever. But I think it's so that the university knows what like services are being used, right? So they can like,
oh,
this is a good thing, this is a bad thing.
yeah,
I don't know. They make me do it though.
makes sense. Yeah, I didn't know if it was like, if Scoggins would apply like extra credit or something for like
No, yeah.
because like I know some teachers do.
They're actually not allowed to do that. I think what I don't have is Angel. Angel, if you'll shoot me your UIN, I would appreciate that. Actually, teachers are not allowed to know who comes to SI. They're not allowed to come to SI. So if we were sitting in a classroom and Scoggins walked in, I would tell him to leave. He's not allowed to be here. He doesn't get to know who's here. It does not positively, I mean, technically it positively affects you because you're learning information, but it doesn't positively or negatively affect you during class at all. I don't know in your grades. I'm not attached to any of that. I'm like totally different, which is kind of interesting. Okay. Cool beans. All right, so I'm gonna screen share with y'all. I'm gonna screen share my desktop with you. Okay, so let's move everything. All right, so we're gonna start with these notes. How does this look on your screen, friends? Someone tell me how it looks.
Yeah, it looks good.
Is this a session 10 worksheet?
This is 11.
Oh, 11. Okay, there it is.
I think, yeah. Right. So you can all see this. This looks good and clear. We're cool beans. Is this good?
Yes.
Cool. So I'm pretty much going to move this or not move this. Go away, little thing. Aha. Okay. So I'm literally just going to scroll as we talk so that it's really clear and you can see it and I can talk through, but it's not messy and we don't have to, you know what I'm saying? We're going to try this. They're going to be a little off, not right now, but like in the future, because I haven't been editing them based on where we stopped in class because he's kind of like just stopping wherever he feels like it. Okay. So last time we talked about bones and the structures and all that. So we are recording, right? It does say that. We are. Okay, so we talked about the bones and their structure and everything about that. So now we're going to talk about skeletal cartilages and the kinds of cartilage and whatnot that are in bone. So human skeletons are made up of cartilage, which is replaced by bone. So when you're born, most of your skeleton is made of cartilage, right? We talk about that. I think it's the hyaline cartilage that makes up most of your skeleton. And then as you mature in utero, you start to calcify or ossify, which pretty much are the same words. They're just different like meanings, but it's the same for our purposes. They're the same. Calcify and ossify in the womb so that your bones start to harden, right? That's why when babies come out of the birth canal, their skull, if y'all, I don't think y'all have done this in lab yet. Your skull isn't fully formed. They have those fontanelles. So it's like there's a bunch of skull bones and then there'll be this little like piece in the middle, and that's pretty much cartilage. It's really squishy and it allows the head to mold through the birth canal without breaking. And so when you're born, a lot of your bones are still cartilage. And that allows for you to continue to grow and develop and come out of the birth canal well. So, right, your human skeleton is made of cartilage, which is replaced by bone, right? Some of it doesn't ever get replaced, like the pieces of your floating ribs that connect right up to your sternum, or like your nose or your ears, right? Things like that that always stay cartilage. So your skeletal cartilage is really resistant, right? Y'all learned about cartilage a lot. It's really resistant. It can take a lot of wear and tear. It's mostly water and there's no nerves or blood vessels in it. So if, I'm trying to think of other pieces of cartilage I could talk about. Right, so if I'm going back to the cartilage that holds your floating ribs up, right, you don't feel that, right? You don't, like, when you press in, you don't really feel that. It doesn't have a sensation or a feeling, which means there's no blood vessels or no nerves. And we can go back to how we talked about that cartilage takes a really long time to heal because it doesn't have that direct blood supply or that nutrients, and so it takes it a long time to regenerate. Does that make sense? Do we have any questions? How are we feeling? Christian gave me a thumbs up. We're keeping hydrated. That's good. If I'm going too fast, tell me. Okay, so
Oh, cool. You can zoom in.
what's happening? Okay, so it ends up having, I don't think you need to know this piece. It ends up having blood vessels that are for nutrient delivery, but it doesn't have any direct blood flow. So they might have little blood vessels that come up to it, but it doesn't have anything sitting right there that it can immediately diffuse through and get nutrients. So the perichondrium, right, is this dense connective tissue that surrounds your girdles. So your perichondrium is going to be in places like your hips, or where your humerus and your scapula meet, right, and your clavicle, in places like that where there's a lot going on, and it's usually a ball and socket joint. Oh, hi Riley's puppy. A ball and socket joint where there's a lot going on, and we're going to have to attach that, right? So the perichondrium is a kind of dense connective tissue that keeps that stable. So then chondrocyte, or cartilage is made of chondrocytes, right? So what does chondro mean?
Cartilage.
Cartilage, Eric, my man. Cartilage, or chondro means cartilage, and cytes means cell. So if you know that beginning and you know your endings, you're going to know a lot about what we're talking about. So your cartilage is made up of chondrocytes that are encased in small little cavities called lacunae that live in a jelly-like extracellular matrix. So these are just like any of the cells that you've seen. Let me actually, can y'all see my webpage? Is that all chill? Hold on. I have a cute little picture of a y'all can see this guy, right, in his YouTube video?
Yeah.
Yeah.
I love the guy.
He's awesome.
Yep. Crash course.
Cool. So this is in the bone, right? But essentially, this is what we're talking about. If this is our chondrocyte, right? This is your lacunae, this little kind of like area. Is it gonna? Yes. Okay, well, we're talking about chondrocytes, but I wanted to give you a visual, right? So this is going to be your chondrocyte, and it's going to have this lacunae where it lives, right? This whole weird jagged piece, and it lives in this whole, and the chondrocytes live in this whole thing called your extracellular matrix. And what I like to compare that to is like if I'm the chondrocyte, my apartment is my lacunae, right? Or wherever you live, your house or whatever, your room is your lacunae, and then we live in the air, right? Us as chondrocytes, we live in the air that's our extracellular matrix. So everything that's just kind of around us, right? Almost like a clownfish is your chondrocyte, the anemone is the lacunae, and the extracellular matrix is water. Does that make sense?
Yeah.
Yes,
Yeah.
cool. Cool. I like to, because if you can put that in your brain, the big words like extracellular matrix and lacunae aren't going to be as scary if you have like a really good visual for it. Right, they're just like little cells. Okay, so cartilage grows in two ways. What are the two ways cartilage grows? Hit me, I believe in you.
Appositional.
And, yes, that's for sure good. Yes, and?
Interstitial.
Oh, yes. I thought it was endochondral. Yes. Appositional and interstitial. I think that's spelled. Okay, so these are the two ways. One of them ends up growing outwards and one of them ends up growing longer, right? Okay, so appositional growths. Okay, in appositional growth, your cells in your perichondrium, right? We said the perichondrium is that dense connective tissue that surrounds girdles. right, secrete matrix against the external face of the cartilage. So it's secreting more stuff on the outside to build it up. Okay, I'm gonna find this YouTube video. See if I can do this. Can you see both of these?
Yes.
Yeah.
Cool. Let's talk about that for a second then. Oh no, what did you do? Natalie? Okay, whatever. I know this is kind of like me being crazy. Is this working okay? Is this better than what we did last time?
Yeah.
Yes? Christian has no feelings or thoughts? He doesn't care. Okay.
Fine either way.
Okay. 2 seconds. Okay, we'll go back to that. It's fine. We'll go back to that. I don't want it yet. Okay, so appositional growth, right? So we're secreting matrix on the external surface, which means we're continuing to grow up, just like if we're growing from Erickson's kitchen. In the basal layer up, right, we're continuing to push out, just like in your epiphyseal plate, right? We start to push out, right? These are just kinds of growth that allow us to grow in length, okay? So the new matrix is laid down on the surface of the cartilage, so almost like we're just stacking new cells on top, right? Okay, so then your interstitial growth, right? Your chondrocytes within the lacunae, right? Same cells, same place that they live. They divide and secrete, expanding new matrix from within. So your interstitial, think of literally the IN in interstitial, right? The IN in interstitial, right? It's within. Right, so the appositional growth is outside and the interstitial growth is within. Does that make sense? I feel like that. If you know what interstitial growth is, then you know that oppositional growth is the other one, right? Okay. So yeah, so they create new matrix within the cartilage, whereas these have new matrix on the outside. These have new matrix within the cartilage. Yes, good. Cool. Questions, feelings? Cool. Okay, so, all right, we talked about how when we're in utero and we're little BBs, right, our bones are mostly cartilage, and then as we continue to develop in utero, our bones continue to calcify. So, right, ossification, the definition of ossification is bone tissue formation, right, aka osteogenesis. Osteo means what?
Bone.
Bone.
Awesome, killing it, Eric. And genesis means?
New or creation?
Yeah, dope. I'll take it. Right, so that means we're just creating new bone, right? We're calcifying it. Okay, so this begins at month 2, right? In utero, right? We start to calcify and ossify these bones, right? And it happens after you're born until early adulthood, right? You grow and you have those growing pains and you get taller every summer until you're about an adult. So probably all of us are the right height that we'll be forever, unfortunately. Or good, whatever makes you happy. But your bones calcify up until then, right? That's why a growth plate is so important, because when you're young, right, it's still going to grow and push new cells and make that bone taller and taller, but therefore making you taller and taller, right, until it ossifies and it becomes that epiphyseal plate, right, and then it is done. Okay, so this happens to us. Your bones develop all of your life. They might not grow in length, but they're going to continue to develop all of your life, especially when we're talking about what sports you play, or if you're in the military, or if you lift, or if you sit on the couch. Your bones will reflect the activities that you do in your daily life. That's so this is what we're talking. So the formation of the bony skeleton. So at about 8 weeks, which is 2 months, right? The fibrous membranes and hyaline cartilage of the fetal skeleton are then replaced with bone, which is pretty much just what we've said in a different sentence. Okay, there's 2 methods for that, which is endochondral ossification and intramembranous ossification. Right, so I know you're writing here. So for our cartilage grows appositionally or interstitially, and then when we're creating that bony skeleton in utero, we have endochondral and intramembranous. Hello, Riley, and her dog's background. That was funny.
Sorry about that.
Okay, so for endochondral ossification, all bones below the skull except the clavicle. So everything from here down, other than your clavicles, undergo this endochondral ossification, right? Right, it begins in the second month of development, right? We have month 2, month 2, month 2. So the second month of development, your bones start to harden, right? Which is why probably, I can't remember when they start to kick, right? But when they start to kick, there's some force behind that, right? Because their bones are ossified, they can move that. They're kind of strong. Those things are fighters, man. Serious, it's some scary things.
How do you know?
All right, I don't know, but I've seen some like wicked videos, and you like see the whole foot. You know what I'm talking about? I'm like, whoa. It's like real alien, like way real. Okay. So they use that previously, the hyaline cartilage. The hyaline cartilage is that cartilage that starts out, and they break it down and that allows ossification to start to begin. I really don't like that this is like a little sideways. It's okay. Right? So we begin ossifying at the primary ossification center. I'm going to show y'all a video of this, and then we're going to talk about it, because it's so much easier if you watch this, because I was trying to draw it the other day, and it was annoying. Here we go. Okay, let's see. John Green is my homie. All right, so, okay, can y'all hear that when he's talking?
I don't think so.
No, you can't. That is interesting. I wonder if I can hold up. Let's try this. Can you hear it now? Oh.
No.
No? Okay. Well, just watch this. So this is how your bones ossify. I can just talk through it then if you can't hear
Oh,
it.
put the
That makes it
captions
easier,
on.
right? So this is our little baby fetal bone, right? Maybe in the very early stages. Okay. And so then we're going to have this. This is our primary. I'll make it full screen. This is our primary you'll see my mouse, right?
Yeah.
Yeah.
Cool. So this is your primary ossification center, right? This is our little hyaline cartilage bone, and this is our primary ossification center, and that's the first thing to start, right? And then once we've made that, our next step is to have this bone color. And okay,
Ooh,
so
we
start to make this bone color, right? Let's see. Okay. So see, so the bone collar forms around the diaphysis of the cartilage. Diaphysis is where?
The middle.
In
Middle.
the middle of the bone.
It's the middle, right?
Can y'all hear me?
Yeah, I can hear you.
Okay, you're just not
Yeah.
answering me. Okay, the diaphysis is the middle, and the epiphyses are on the end. Okay.
I guess you didn't hear whenever.
Krishna, I can't
Everyone
hear you.
said the middle.
I said that
Why are you laughing?
because I said the middle.
Why is it doing?
I don't think she can hear us. Can you hear us?
Yeah, can you hear us?
Now I can hear you. What were you saying? I'm sorry.
We said diaphysis, but yeah, you couldn't hear us.
Shoot. And I just was like, no one knows. Okay, whatever. Good, that's good. Okay, so you start
And
with
someone told you to turn the captions on
Alright.
Yeah.
for the video.
So I can do that. Why? I mean, I can.
Then we
Okay.
can watch the movie.
True, that's fair. Okay, well, so we make this bone collar that occurs in the diaphysis, and then central cartilage in the diaphysis calcifies and develops the cavity, right? Because we're going to have a medullary cavity in the middle of the bone. And what does that hold in
Marrow?
adults? Yeah, in adults, what color of marrow? Red or yellow?
Yellow.
Yellow.
And in babies?
It's red.
Red.
Red, right? Because they store a lot of their fat other places, and they need that blood cells. They're making new blood cells, right? Because they've been using the mom's blood and the fetal and mother blood. That's too. But anyway, let's not do that. All right, closed captions are on. right? So we have osteo, this is an osteoblast, right? So see this medullary cavity that's starting to happen, right? We're opening up this cavity and cartilage is forming in the middle, right? And then we're gonna start to do this periosteal bud, right? Which leads to the spongy bone, right? This is when we start to make up that, when we start to make those trabecula, okay? Okay, so up here we make, so the periosteal bud, right? And then we start to get trabecula up here and down here. And then your final stage is when your diaphysis elongates, right? So the middle of the bone gets longer, right? And then we start to ossify the epiphyses. I know this video is like really fast, so let's watch it again real quick. Okay, so we have this, and then we have our primary ossification center right there. Okay. And then we get the periosteal bud and things, and we start to make that cavity, right? And then we're gonna form spongy bone here and here. And then our diaphysis is elongating, as you see. And then your ends, your epiphyses will ossify last, okay? And that happens after you're born, okay? And so these are those epiphyseal lines and epiphyseal plates that will end up growing, okay? What did I want anything else in here? Okay, no. Okay, does that picture help you what we're talking about?
Yeah.
The video?
Yes.
Okay, cool. I feel like the video is helpful. Why is this sideways? It's really making me mad. Okay. So that's in utero, right? That's endochondral, and this is intramembranous. Intramembranous begins with the fibrous connective tissue, right? Formed by mesenchymal cells. Okay. This forms your skull and your clavicles. Remember, everything else occurs via endochondral, and intramembranous is your skull and your clavicle bones, okay? Right, so that's why it's saying frontal, parietal, occipital, temporal clavicles. For a lab review, tell me where the parietal bone is.
The side of
Up here.
at the
Top.
top.
Okay, tell me where the frontal bone is.
Up here.
Head,
For the head.
Okay, occipital,
back,
Back. Back bottom.
back. What about temporal?
Side.
side.
That side.
Right here. And then where are your clavicles? For funsies.
Down
Oh, boom.
here.
Oh my goodness, the clavicles. Good, good. So, right, endochondral is everything except for your skull and your clavicles, and intramembranous is head and clavicles. I want to say like head and shoulders, but it's not. It's head and clavicles. Okay, so for this, we have one ossification center. So we have an ossification center, right? These mesenchymal cells cluster and become osteoblasts, right? So these cells, I don't necessarily need to know what the cells do, but they end up becoming osteoblasts. And what do osteoblasts do?
They secrete the bone
Yes.
stuff.
So blasts build. So osteoblasts are making bone, right? The osteoid, right, is then secreted and calcified. Do we remember what an osteoid is?
It's the cell, right?
It's the structural unit. I think it might be in the other session. Or no, it's over here. It's the structural unit of the bone. Let's go back. All right, so an osteoid, right, is secreted by these osteoblasts, and it's a third of your bone matrix, right? It's just a piece of your bone. Okay. So then it's secreted and then calcified, right? So we start to secrete that bone via the osteoblasts, right, in the ossification center, right? And then, what is this? Okay, then bone is woven and laid with blood vessels, okay? And we start to form those trabecula, right? And then your lamellar bone is replaces the woven bone, and red marrow appears. So we have this woven bone that's coming in, and then your lamellar, right, which is those, like, you remember the circumferential and interstitial lamella, right? Those rings come in and replace that, and then red marrow comes in it, right? So I don't know. Let me see if I have a video of that one. Oh, all these things don't matter. If you do, okay. Okay, here we go. Can we see this?
Yes.
Cool. So, right, these are some mesenchymal cells, right? And they secrete this osteoid, right, which are the little dots. And then the osteoblasts are those little red cells. So they're starting to secrete those little freckles, speckles of osteoid, okay? And then the osteoblasts continue to do this, and they're starting to make bone tissue, right, which is this tan stuff, right, or osteon, right? And it continues to calcify and create more and more of it. And then we have this woven bone, right? We start to get this woven bone, and we're seeing some blood vessels coming into it. And then finally, we replace all of that, and we have full-on trabecula, and we have blood vessels that are innervating, okay? So this one's a little different because the clavicle and the skull bones are flatter, and they don't have diaphyses and epiphyses and things like that, especially in your skull bone, because those are flatter bones. Does that make sense? Yes, picture is good, bad?
Yes.
We're chilling? Okay, we're chilling. All right, let's go back. All right. So why I want this to like, can it be over here? Okay, that's fine. All right, so those are kinds of growth. So what bones are grown via intermembranous ossification?
Say it one more time.
Intermembranous ossification creates which bones, or ossifies which bones?
The head and clavicle.
Yes, and then endochondral ossification ossifies which bones?
Everything else.
Everything else. Yeah? Okay, so it's important that in that endochondral ossification, we have 2 ossification centers. They really like to ask you about which one has multiple ossification centers. Your endochondral ossification has 2 ossification centers, right? We have the one in the middle, and then we have ones that form at the epiphyses, okay? But because that intermembranous it just kind of is doing a flat thing, right? It's not going everywhere. It's kind of doing it all at once. There's only 1 ossification center. Does that make sense? Eric, are you like alive, or are you laying down, or are you not there?
I think he's dead.
MIA, coronavirus. It's fine.
Mm.
Okay, so now we're growing in the length.
There he is.
Oh, there he is. I called you
Keep
out.
the timer went off.
Jesus.
Gotta get it before burnt.
Okay. All right. So the length of long bones. So long bones are grown by interstitial growth, right? Which means what?
Inside or within.
Yes. Christian, how did you remember that?
The in and within.
Woo! Now that's a star right here. Cool. So interstitial growth means we're growing from within, right? This is longitudinal growth. This is when your bones are getting longer. This silly thing makes me want to throw it. I'm so sorry. Okay, so that means your bones are growing longer, right? This growth occurs at the epiphyseal plate. Did we know that?
Yeah, duh.
Eric. Okay, right, so that epiphyseal plate will allow us to push, right? Push and make new cells and make the diaphysis longer, okay? What is that one? Okay. So then there are 5 zones in the epiphyseal plate, okay? Also, this little chart is kind of like a cool little side-by-side what's different about endochondral and intramembranous ossification, okay? All right, so we have a resting zone, a proliferation zone, which kind of just means dividing. We have a hypertrophic zone, a calcification zone, and an ossification zone, right? So we rest, we start to divide some more, we calcify, and then we ossify. Okay, so we're going to talk about these. So your resting zone is inactive. We're just kind of chilling. No big deal. Everything's cool. We don't need to change anything. Okay, right? So the epiphyseal side of the epiphysis, and it's just chilling. Okay, your proliferation zone, right? Pro and then life, kind of, right? So we're starting to create new things. So we're replicating, rapidly dividing, right? We're pushing new cells up so that the diaphysis and it lengthens. Does that make sense? Proliferation zone. Yes, cool. Your
Dividing,
hypertrophic
increasing.
zone, yes. Your hypertrophic zone, old chondrocytes. So they're enlarging, where they're getting bigger, the chondrocytes are, and they're connecting, right? Almost like they're going to form that trabecula, right? So we're getting longer, and the old chondrocytes are becoming closer and closer to the middle, right? Almost like, no, we won't do that. It's confusing. Okay. I'm going to show you a little video of this in a second. So the calcification zone, right? The surrounding cartilage matrix calcifies. So we have all these brand new osseous cells, and so now we need to calcify them so they're hardening, okay? So then, once we're starting to calcify them, and then at the end in the ossification zone, they're ultimately replaced with spongy bone, and they start to get calcified, right? So we create new stuff, we create trabecula, we start to calcify them, and then they're ultimately replaced with spongy bone, so we're continuing to lengthen and lengthen and lengthen.
The fuck is going?
Let's see. Is it in this one? No. Oh, wait, also I'm zoomed in. Hold on. Okay. He's thinking. Okay, right, so epiphysis, diaphysis. Right, so this is the epiphyseal plate, right? And so it's made up of chondrocytes, right, which are kinds of cells that create cartilage, right? And then they start to make cartilage, right, as we go out, right? That's what the little arrow says. We're making more of them, so we're pushing out more. Right, we're pushing out on both sides, and then we end up getting longer, right, because we have more of them. Right, we're proliferating. And then at some point, right, when we're done growing or whatnot, the epiphyseal plate might be up here, and we've created new bone, we've lengthened. Okay, let's see. Okay, so right, so your cartilage is growing and growing, and it's creating, like, it looks like compact bone, and then as we go out farther and farther, it ends up becoming spongy bone full of trabecula, right, because we're lengthening it, we're giving it more surface area. Okay, how are we doing? Are we dying? It looks like everyone's dying. Ashley, Angel, Keely, Eric's eating. How's everyone else doing? How's everyone that doesn't have video on doing?
Good.
Good?
Yeah.
Okay, I know. I'm sorry. All right, so at the end of adolescence, our chondroblasts, right, are things that are creating cartilage, right, which allow us to lengthen our bone. What is this? Allows us to lengthen our bone. Are nice. Thank you for the wink, Angel. Why is this? Why won't this go away? Go away. This is. I'm sorry. I'm dying. Okay. Right. As our chondroblasts start to divide less, our bone stops lengthening, right? And then your epiphyseal plate is replaced by bone. It's no longer cartilage right there, and it stops growing, right? The epiphysis and the diaphysis, right? Because there used to be cartilage right here between my hands, and then when we're done growing, they fuse, right? And they're all bone. It's all calcified and ossified. Okay, in females, this happens around 18. I think it's after like 2 years of having your menstrual cycle. And then in males, it's 21. So if you're not 21 and you're male, there's hope for you. The rest of us, maybe not so much. Anyway, thank you, Eric. Okay, so now we've done length. Okay, so how do we grow in length for bones?
Interstitial.
Boom, roasted. Yes.
I was
Right. Okay. What, Eric?
I was gonna answer, but I was chewing.
Snooze, you lose. All right, so now we're gonna grow in width of bones. Your lengthening of your width, your growth in width is appositional growth. I'm sorry, I'm dying because Eric keeps turning his video off, and I know it's because he's eating pizza. Because no one wants to sit here.
You want to
like-
watch me eat pizza?
No, I just think it's funny because you keep like going black, and I'm like, he's eating pizza.
Mhm.
So we're growing in the width of our bones. Now our bones are nice and long, but they're like really skinny, and so we want to make sure that our bones are growing in width. This is via appositional growth. Okay, so your bones thicken or get wider via muscle activity, stress, or added weight. So if you gain weight, if you start to work out more, if your bones are undergoing undue stress, maybe it's not from lifting, maybe it's from sitting on the couch, maybe it's from being an astronaut. I talked about that last session about how astronauts have to make sure that they're working out a lot in space because they don't have that gravity on them, and so there's not as much force on their bones asking it to remodel and grow and continue to become strong. So it's really important that they work out so that they can continue to remodel those bones and keep them strong in width, right? So your bones are changing all the time, right? Appositional growth is width. So your osteoblasts, right? These are your beneath your periosteum, and they secrete bone matrix. When we're saying secrete bone matrix, it pretty much just means we're creating new bone matrix, right? We're creating new stuff, new bone pieces, right? Which means we're growing the bone, okay? Osteoclasts, however, remove the surface of bone, right? Clast means to break down. So let's see. Go away. Go away. Can y'all see this little like thingy that I'm moving around?
Yeah.
Okay, cool. I'm sorry. I know it's really irritating. I just don't know what to do with it. Oh, so remember I was trying to draw all this for y'all last time? So this is like a cross section of a bone, right? So what are these rings around the very edge called? It's a kind of lamella.
Oh, the rings?
Yeah, so these outer pieces right here, right? It's a kind of lamella. We have circumferential and an interstitial. The ones around the outside, what do you think they are?
Circumferential.
Yes. Yeah, if anything, think about circumference, right? The whole thing is when we're talking about circumference, and then these little cross sections right here between the osteons, right? Those are your interstitial lamella, right? Because they're between everything, right? I know that my drawing was not great, but this is what I was trying to draw. Okay, so, right, so we have osteoclast. Why is, okay, just let it play for a second. Okay, osteoblasts, bone makers, and osteoclasts are bone breakers, right? So osteoblasts are creating new matrix on the surface. Look how cute they are. Look at those stupid little cells. They're so cute, right? So they're making bone, okay? And then the osteoclasts will secrete these digestive enzymes when we want to break down the bone and get rid of it, okay? Okay, cool. I just like showing you those little cells because they're pretty cute. I don't know, I like the animated cells. Okay, so when we break down less than we build up, what is it? Break down less than build up. Okay, so when we're building up more bones than we're breaking down, we have really thick, strong bones, right? And they're not that heavy. Okay. So we're going to talk a lot about. We always talk about. Hi, kitty cat. We talk a lot about homeostasis, right? Because it's okay. Your cat can be in the video. Right, we have to make sure we're building up and breaking down bone at the right rate so that we're not having bones that are too heavy and too thick, and we're not having bones that are too thin or too brittle, right? We want to make sure that we're utilizing them in the right amounts because there's minerals and salts and things in the bone that we like to use, but we want to make sure we're doing it at a good ratio. Okay. In talking about that, we get to talk about hormones. Okay. So we have lots of kinds of hormones, right, that allow the regulation of bone growth. We have growth hormone, right? This actually stimulates the epiphyseal plate to grow. Every time you see EP in a key, it's epiphyseal plate. I'm not writing epiphyseal plate that many times. So this stimulates the epiphyseal plate to grow in childhood, right? You remember when you like wake up in the middle of the night and you feel like your shins are gonna fall off your body or your like femurs, right? It's because you're growing and those are growing pains. And then your thyroid hormone, it modulates, so it pretty much controls the growth hormone. The growth hormone controls the epiphyseal plate, and then the thyroid hormone is like its parent, and it's like, it's time to grow, tell it to grow, and it's like, okay, grow, right? It's like the parent of it. And then testosterone, right, and estrogen, so those stimulate the puberty and growth of length and width of your bones as you enter puberty for males and females. Right, and so any excess or deficiencies in these hormones will relate to different kinds of bone growth, right? So, and I think we talk about, I think diseases is in the next like little bit. So we'll go for another like 10 or 15 minutes if that's okay with y'all, and then we'll be cool beans. How do we feel about that? You feel okay about that?
Sounds good.
Here. Okay. Cool. Are we feeling, do we have questions about the information before we switch over to session? I'm gonna, oh, am I on? Oh, we're on, that was on 10. All right, we're gonna go up to 11. So, right, before we switch over to this, does anyone have any questions about the last material? Any clarification? Do we feel like that was an okay amount of information?
Yeah, that was good.
Yeah, cool. Cool. I like this better. I think this works better because then I don't have to write, and you know what I'm saying? If you don't want to write, you don't have to, whatever makes you happy, because I think explaining and talking about the information is more important than writing.
Things running much smoother.
Agreed. I don't feel so tired. Okay, so remodeling, we're going to use the word, so we're on session 11 now, and I'm going to post all of this, so like if you don't want to write it down, I don't care, whatever. So bone remodeling is pretty much just meaning we're either breaking down or building up bone, right? So we're just remodeling the kitchen, aka our bones, all the time. So 5 to 7% of your bones are recycled each week, which is crazy. So 5 to 7, yeah, I know, right? 5 to 7% of your bone are recycled each week. So sometimes it's for hormones, sometimes it's for calcium, sometimes it's for minerals, right? We're constantly using the stuff in the bones and building and breaking them down all the time, which is crazy. So your spongy bone is replaced in its entirety every 3 to 4 weeks. That's crazy. And then your compact bone is replaced every 10 years, right? That's that outside piece of the bone. That's the really smooth, flat piece that if we were to like pick up a bone, like a cow bone that was outside or whatever, because we live in Texas, right? That's the part you're gonna see. And then that weird like jagged piece in the end, Farley's killing me. This weird jagged piece in the middle, right, is the trabecula, right? And that's part of the spongy bone, okay? So bone remodeling occurs at the surface of the periosteum and endosteum, okay? And so packets of osteoblasts and clasts coordinate remodeling, which just means the osteoblasts, which make, sorry, it's not mirrored, so I don't know which direction is right. The osteoblasts, which make, and the osteoclasts, which break down, are talking to each other, right? It's like a good construction crew, right? People that are building and the people that are breaking are talking to each other, and they're making a game plan of when to build and when to break and what to do, right? So that they're all in the same, we end up being in the right homeostatic balance. Because I think at the end of this, we talk about like diseases, like Paget's disease and polio and things like that, or bow-legged, all of those things, or osteomalacia, all of that jazz is all about irregular bone remodeling. Does that make sense? Cool. Yes. Awesome. Cool. So thank you, Eric. Okay, so osteoblasts deposit new bone matrix, right? Y'all knew that. So the mechanical signals, right? So if a bone gets pulled on a lot, this is a mechanical signal, and it's telling the bone that we need more bone. right? We're using it more. Maybe we have more muscle mass, or we gain weight because we're in the plague and we're eating snacks like every 45 minutes. Or maybe we're like running a lot and we're getting a lot of extra pull on stuff that doesn't really get a lot of extra pull. So this mechanical signal increases the concentration of calcium and phosphate ions, which allow us to start to deposit, right, the appropriate amount of bone, right? So the matrix protein binds to the concentration calcium. So what you need to know is the mechanical signals increase the concentration of calcium and phosphate, which allows this enzyme to mineralize and create new bone for us to deposit. Okay. And so then for bone resorption just means breaking down. I don't know why they always want to say resorption, like reabsorption. I don't know, whatever. That's what it means, because people get really confused. They're like, I don't know what resorption means. Okay. Breaking down. So osteoclasts, right? So even if you didn't remember what resorption means, if you know what a class does, you know what resorption means, right? So we're breaking stuff down, right? They dig depressions and grooves and they break down the matrix, okay? They use a lysosomal enzyme. Do y'all remember when we learned about organelles and we learned about lysosomes?
Yes.
Yeah.
Right? So even if you don't, you've heard that before, so we're remembering that, right? A lysosome is pretty much just like a cell of digestive enzymes, right? It's almost like if you had a baggie of bleach, right? And you carried it around and you put things that you wanted to throw away in the baggie of bleach and you let it like just like disintegrate it, okay? They use these lysosomal enzymes that digest the matrix, right? We break it down and then the acidity converts the calcium salts to soluble forms. So what that means and what we care about for that is we're using lysosomal enzymes to break down when it's time. And we're breaking down because we want these soluble forms of the salts. A lot of the time when we're breaking bone down, if it's not for like malnutrition or something like that, it's because we want to use those crystals or the salts or the calcium in our bone. That's what we need. That's why we're building it up and breaking it down. Does that make sense? Cool. I don't know. I don't expect you to like be jazzed, but you know what I'm saying. Okay. All right. So osteoclast phagocytize. What does phagocytize mean?
To eat.
So they pretty much phago means ingest, right, or eat, and then cytize, right? So the cells are eating matrix, dead matrix, and dead osteocytes. So anything that's old, we need to recycle, right? We talked about 5 to 7% of recycling. These osteoclasts do for us. They're pretty much the best garbage men in the whole world. Okay. So they use this to digest products that are then released into the interstitial fluid. Okay. So as we're breaking down things that we don't need, things that have been broken down are released back into the blood, right? And will be excreted as waste if we don't need it anymore. Okay. So then once we're done breaking down the bone, apoptosis of osteoclasts happens. What does that mean? What does this mean? So when we're done breaking bone down, what happens?
Do those cells die?
Right, which cells?
The osteoclasts?
Okay, and what does apoptosis mean specifically? Anyone else? Eric.
Controlled cell death?
Yes. Eric, I got you next time. Okay, so apoptosis is controlled cell death. Okay, so the cell knows that it's time to die and it's healthy and it's good. It's like passing away in your sleep when you're ready, right? The osteoclasts have done their job and it's time for them to go now, right? So when we're done breaking down, the cells that break down die, okay? Because they did their job. So they don't need it. They're off duty, okay? So how we control this resorption and deposit and break down and build up is by hormones, right? We talked about growth hormone and thyroid hormone and estrogen and testosterone and everything. So your remodeling occurs continuously and is regulated by genetic factors, okay? So some people, if you have like a disease, maybe you'll do more or less, right? Or if your genes tell you, if you have certain deficiencies, things like that. So a lot of it's by your genetics, especially because y'all know, like how tall you are is a mixture of how tall your parents are, right? So like if both your parents are short, you're out of luck, okay? But if you have one tall parent, oh, there's nothing wrong with being short, by the way. I think that's like usually what I hear. But so
Yeah, I'm short as heck, so.
hey, it's cool. I can't wear heels. My boyfriend, or I'm taller than my boyfriend. excuse to
Yeah,
wear
that's how my
things.
mom is.
Yes. So there are two control loops that continuously regulate the remodeling of bone, which are your hormonal controls and your response to mechanical stress. So in layman's terms, that means your bones will either build up or break down, whether a hormone tells them to do it or to not do it, or if we have any mechanical stress, right? If we start to bodybuild or we start to run or we start to gain weight, right? So mechanical stress and hormones can tell our bones to do things. Yeah?
Mm-hmm.
Cool. Does that make sense? Okay, so so we have two hormones that are really big for our hormonal controls, and it's calcitonin and parathyroid hormone. Okay, let's just do this video thingy for, let's see, hold up, where are we at? Do y'all want to finish hormones and then call it quits, or do you want to go to fractures and call it quits?
Well, I'm about to go eat, so.
All right,
cool with
everyone,
that.
Eric's already eaten, so what does everyone else want to do?
Stop at hormones.
Yeah? Cool.
I'm gonna go swimming, but I have to wait 30 minutes.
Do you have a Twitter? Because I would just like to hear what happens in your brain all the time. I'm just like never ready for anything you say.
Yeah,
You're like,
honestly.
I'm gonna swim during the apocalypse, but I have to wait 30 minutes because I just ate some pizza. And I'm just like,
Safety first.
what is what is happening? Okay, all right, we'll finish hormones and then we'll dip. Okay, so let's talk about these things. Can this go away, please? Okay, so we have two hormones. We have calcitonin and we have parathyroid hormone. You can't hear him. That is great. I want to show you. Fine. So with your hormones, the thing about these is it seems really scary. If you learn one and you can remember that one, you will know the other one, right? Because the names seem kind of counterintuitive. So if you can learn one and learn it in its entirety, right? Because in our worksheet, we talk about, right, where is it secreted? Where is it released? Why is it released? Blah, 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 right? If you learn all of that for one, then you're going to be able to understand it for the other one, because it's one of them is up and one of them is down. Okay? Okay, so let's see. So I'm trying to get you a picture that will not scare humans. Okay, so this is our picture. So our thyroid, okay, so in your blood, you have a blood calcium level, just like you have an oxygen level, just like you have a glucose level in your blood, right? We're talking about calcium. This is our important bit. So if our blood calcium is really high, which means there's a lot of calcium in our blood, right? So there's a lot of little Ca plus 2s floating around in our blood, right? The thyroid is going to release calcitonin. Okay, so the thyroid sees that our blood calcium level is really high. Okay, and so in response to that, right, because we always want to be in homeostasis, so if we're up here, in response to that, so we're going to release calcitonin, which will decrease our blood calcium levels to bring us back to normal. Okay, does that make sense? Okay,
Yeah.
that's okay. We're going to, people have a really hard time with hormones. What's up, Eric?
What's calcitonin?
Calcitonin is just the hormone. You can look it up if you want. You can look up the structure. Calcitonin is just one of your hormones, and so it decreases your blood calcium level.
Oh, so it decreases Ca2 levels?
Yes, I'm going to go back to the worksheet in a second so you can do that. So where are we getting the calcium in the first place, human beings? Where is it coming from?
Bones.
Bones?
Yeah.
Got it.
So if our blood calcium level is really high and calcitonin lowers it, do you think it breaks down or builds bone?
Breaks.
Build? Right.
Well, how am I wrong? You're giving me the wrong look.
There's like
Is it-
5 people, Eric,
is it-
you never know. So we have high blood calcium levels. So we want to get rid of it. The calcitonin gets rid of it by either breaking down or building up bone. What do you think?
If you're getting rid of it, then breaking down, right?
I'm so confused.
So you want to use it, so you want to build more to get rid of it, right?
So if we're saying the calcium comes from the bone, when we
Okay.
break down the bone, we get calcium out of it. Okay.
Oh, that makes
Okay.
sense.
So you get calcium out of the bone when we break it down. So if we're trying to get rid of it and calcitonin allows us to get rid of it, we're going to deposit into the bone, right? Because we
Yeah.
want to get rid of that calcium. And where do we store our calcium?
In bones.
In
Well, you're not
bones.
getting rid of it. You're just putting it somewhere else.
Yeah,
So
yeah, yeah.
I was right with what I just said a while ago.
I don't know, say it again.
Yeah. it was-
So does it build or break?
So it
Calcitonin
builds.
Okay,
builds
that's right.
by getting
Okay.
rid of the calcium that's in your blood.
and
Okay,
it
so
deposits it
cool.
into the bone.
Cool. So it's secreted by the thyroid gland. It's released by certain cells in the thyroid gland called parafollicular, okay? And it decreases your calcium level.
Say that 10 times fast.
I know, that's why I want to do one and then we'll do the other hormone, because if you understand calcitonin, parathyroid is just the opposite. So hold up. So I'm going to say all of it again because, right. So we have let's go back to the picture though.
Ask a question. I'll be able to answer it over this.
All right, Eric, I'm going to explain it and then I'm going to ask you again. Will you just get it signed? Okay, so we have high blood calcium levels because we have too much of what in the blood?
Ca+2
Cool. Where did we get it?
from the bone.
Cool. So then the thyroid releases what? I know it's on your screen, but tell me. The thyroid releases what?
Calcitonin.
Calcitonin?
Which does what?
It builds the bone.
Builds the bone.
Deposits it back into it.
Cool. So that's awesome. So if it's building bone, what happens to the blood calcium level?
They go back down. They
It
regulate.
goes normal, it regulates.
Boom. Yes, Christian gave a clap. I'll give you a little clap. Cool. I know it's on your screen, but talking through that is huge because it's really confusing. Okay. So then parathyroid hormone. Okay.
Does it deal with
Oh,
the
this
body?
silly little thing makes me crazy. Okay, so parathyroid hormone. The blood calcium level is really low. We don't have any calcium in there and we need some, okay? So it's really low. So then the parathyroid gland releases parathyroid hormone. So that one's really easy. Parathyroid gland releases parathyroid hormone, which increases the blood calcium level, getting it back to normal.
Break down. Does it
Yes.
break it down?
Yes, because if we have no calcium and we're storing the calcium in our bones, then we would have to break down bone to get more calcium out of it. Does that make sense? Good. Anyone who doesn't have their video on, does that make sense?
Yeah.
Yes?
of.
Okay. Okay, so then your parathyroid hormone is secreted into the blood because we have low blood calcium, right? And so what's stimulated is osteoclasts. Eric, why are osteoclasts stimulated?
That was a hard one. What'd you ask me?
No, you just told me it. You just got to remember what an osteoclast does. What an osteoclast do?
It's in the matrix.
Breaks apart?
It breaks down
Yeah,
the bone.
so it breaks down the bone, which is what you just told me. So we break down the bone via osteoclasts and therefore
Release
increasing
calcium.
blood calcium levels because the calcium comes out of the broken down bone into the blood. Tell me how you feel.
I thought the other thing broke down the bone. So is that can you go back to the picture?
Yeah.
Parathyroid hormone, is that like the parent that tells them to do it?
So the gland, the parathyroid, releases because that was what I was talking about with thyroid hormone. Your thyroid regulates growth hormone. Okay, but this is a different thing. Your parathyroid, okay, releases this parathyroid hormone because of low blood calcium, which breaks down bone via what thing, Eric? How does bone break down? What cell?
Osteoclast.
Boom, which releases calcium out of the bone into the bloodstream. Calcium goes up, homeostasis. Flatten the curve. Ooh, that was funny. Oh my gosh. I don't care if y'all thought that was funny. I thought that was funny.
Nerd.
Yes. Okay, so we can
So-
stop now. And and hit me with questions. What's up?
Oh, I don't have a question. I was saying bye.
Okay, bye. I haven't posted the video for session 10 because y'all's faces are in it, and I don't know how the department feels about that. Your names aren't on it, it's just your faces.
I bet my face looks great.
Are you gonna be able to hear us?
It's just your dog. Yes. So
They're
you're
gonna love
obviously gonna be YouTube famous. Yeah, no. Shout out to Eric, the homie.
Save it
Don't-
for my dog.
Yes, it'll just be your dog.
They're just gonna see
So
a video going on and off eating pizza.
yeah, for sure. That's why I wanted to call you out. So I will let y'all know. I have a department meeting tomorrow, and I will let y'all know. I might have to edit your faces out. I might not, and I will post today and Tuesday's session, and then we'll have session again on Tuesday. Did this work better than last time?
Yeah, it was
I
really
wasn't
good.
here, but like it worked pretty well for me.
Okay, I appreciate that. Good.
A lot,
Good.
like it's a lot smoother.
Agreed. My time was rough. So, all right. So we'll pick up here on Tuesday, and then we'll go through the rest of this packet and hopefully start joints, because then we'll be just a hair behind lecture. So let me know if you have any questions. Stick around, chat me, whatever you need to do. Angel, I don't think you ever snapped or texted me your UIN. If you could do that, I would super appreciate it. But
Oh yeah.
always.
Are you putting the like the keys and stuff like you used to online still?
Yes.
Okay.
All the keys are going online. All the videos that I showed you are in the YouTube playlist. So if you want to go and watch one, I recommend that. Some of these videos are killer because it's really important to see this stuff. So enjoy your pool. Don't drown. Holler if you have any questions, and I will see y'all on Tuesday.
Bye, friend.
Wow.